All right, guys. Let's keep on keeping on. All right, we're talking about scatter plots. So this is all statistics. This is the last half of chapter 3. All right, so our objective here is I can construct a scatter plot to model data and identify and interpret relationships between data sets. That's our objective. New vocab, scatter plot, cluster, gap, outlier, positive, negative, strong, and weak associations. Positive, negative, strong, and weak, we all talk about associations with that, but I didn't want to waste all that room writing associations like 4 times. So, we got this data set right here. TJ wants to promote his new YouTube channel about drop shipping. He wants to optimize the number of subscribers that he gets with every new Instagram post based on the data below. What should TJ's strategy be for the number of posts he makes per day promoting his new channel? So if you take a look at this table right here, we've got just the number of posts made per day as he is promoting it over the course of whatever, how many days is this? 1, 2, 3, 4, 5, 6, 7, 14 days, so 2 weeks. When he makes one per day, he gets 40 new subscribers, right? And we can see that we have kind of a positive trend going as the number of posts per day he makes goes up. He gets to like 110, 120, hitting around 5 per day. But then once he starts to hit 6, it actually starts to go down. So we have kind of a negative trend happening the more posts he makes past 5, right? So based on that, we can if we have just a real simple graph right here, right? Posts per day would be right here, and then new subscribers right here. It's kind of like as he's going up and then he hits 5 days and it starts to go down like that. So it's a positive trend here and a negative trend right here. So what should his strategy be? Well, this is kind of the sweet spot right here. That's like the maximum number of subscribers he gets based on how many posts he does. So his strategy would be something like TJ should post no more than 5 times per day, because when he starts to like saturate and kind of like over posting, right? And so people kind of get sick of it at this point. So the number starts to drop when he does 6 or more. So yeah, stick to 5. He should be good. Now we've got all this data right here. Kind of the same situation. He begins analyzing the data collected to determine how long after posting a new product on Instagram that he gets the most number of views. His data, I know you're like, shouldn't that be, his data is presented, but data is actually plural. So his data are presented in the table below. How can he determine his data are? Let's see. His horses are, yeah, data is plural. How can he determine whether there is a relationship between the time after posting and the number of new views? So we have just like some Instagram posts with some data about those Instagram posts, right? We've got time in hours on our x-axis and then number of new views on our y-axis right here. So we're just going to put these on here. So his first post, after 2 hours, he had 700 views. So we'll go over here, put that right there. So 6, he got 100. Here, 3, he got 1,000. No, my bad. That's not right there. That's inaccurate. Let's see, because I think I'm getting confused here. 2, 700, 6, 100, 1, 1,000. And that's a mistake right there. Okay. All right. 3, 400. Okay. 4, 300. 7, 50. So actually right there. And then 3, he got 500. Okay, so again, that's a mistake. My bad. So we have kind of this we could call this a decreasing graph. If we talked about qualitative graphs, this would also be kind of a negative trend right here. So how can you determine whether there's a relationship between the time after posting and the number of new views he gets? Well, we can see that as time goes on, he gets less and less views, right? And so basically, when he first posts something, right, the algorithm probably pops it out to the most people. But as time goes on, the algorithm sends it out to less and less people, right? So he would say the relationship between time after posting, that's our x value, right? Time after posting and number of new views, that's our y-axis, our output, number of new views is negative. Okay. So as time goes on, the number of new views decreases. Okay. So he gets the most bang for his buck kind of like right after he posts it, right? That's where he got that highest number of new views, right? Is after that hour. Okay. That's kind of how you analyze this data. It's like that. Okay, cool. All right. David asked 10 students how many hours of sleep they got the night before math test and then matched that data with their grades. He plotted his data in the graph below. Did students who slept more get higher test scores? So as we kind of look at this, we can see that we've got kind of like an upward trend, right? We have kind of a positive trend. So basically the more hours of sleep you got, the better you did on the test. Generally, of course, but we have this dude right here, okay? This dude slept 10 hours and failed it with a 40%, right? So we do have something called outliers, right? This is a data point that doesn't fit with the rest of the data. And honestly, like in real life situations, you're going to have outliers like this where you have points right here where it doesn't fit, right? All this stuff is kind of in that general trend, like the more sleep you get, the higher your test score. But sometimes, you have some kid who just didn't do well on the test. He still slept 10 hours, right? Gap is a space where you have no data. Okay, and then a cluster is when there are a lot of data points close together. So like right there, okay? All right. Construct and interpret a scatter plot. Avery is the middle school basketball statistician. She tracks the number of minutes a player plays and the number of fouls the player makes. Her data are shown in the scatter plot. Is there an association between the number of minutes played and the number of fouls made? Well, if we look at this one, we can clearly see that we could draw a line through that data, right? Even this one right here, even though it's kind of like a curve, we still got that kind of like negative slope. We could put a line through that data if we wanted to. This one right here, though, it's kind of all over the place. We can't really draw a line that makes sense through this stuff. That was a mistake right there. So is there an association between the number of minutes played and the number of fouls made? Not really, okay? So we'd say no, there is not an association, not a relationship, you could think about it like that, between minutes played and fouls made. Look, I rhymed. Okay, so no association is when you can't draw a line through the data. That makes sense. I mean, I could draw a line if I wanted to, but it wouldn't make any sense. Okay. Okay. A positive association is when you can draw a line through the data with a positive slope. Okay, so like right here, it's a positive slope. That's an increasing graph. Negative association is the inverse, the opposite of that, right? So when you draw a line through the data, but it's a negative slope. Okay. When you can draw a line through the data with a negative slope. Okay. Solve this question here, solve this equation for x. We're going to add 4x to the other side. Okay, because that's the opposite of that being negative. Those are going to cancel. Negative 5x plus 4x is negative 1x minus 7 equals 20. We're going to add 7 over here. We get negative x. It's the same thing as negative 1x equals 27. Now, actually, I'm going to keep that negative 1 right there. We can't have a negative variable in our final answer, so we're going to divide by that negative 1 to get rid of the negative. Then we transfer it to the other side to get to x equals negative 27. Well, there we go. That was pretty fun, huh, guys? Statistics.